Imagine, just for a second, a hidden danger. Something lurking in, well, your daily life. Maybe a refreshing swim on a really hot day, or even just using a neti pot.
Right. Things you wouldn't normally think twice about.
Exactly. We're talking microscopic, potentially deadly, and often where you least expect it.
Today, we're taking a deep dive into the, frankly, chilling world of free-living amoebas.
Often called brain-eating amoebas in the news, yeah.
That's the one.
And they really are organisms too small to see, but they can have a truly surprising, sometimes devastating impact on human health.
And they seem to be making headlines more often lately.
They do.
Yeah.
Understanding them is becoming, well, pretty crucial.
So to guide you through this, we've pulled together quite a stack of sources. We've got detailed medical parasitology reports, direct insights from the CDC.
Good stuff.
Recent news articles, too, highlighting some concerning outbreaks, places like India and the U.S., and even some cutting-edge research on water treatment.
Which is really interesting, yeah. So our mission today, let's try to demystify these creatures, figure out how they operate, the risks they pose, and crucially, how you can protect yourself, your community too.
Okay. Sounds like a plan.
All right, let's unpack this then. What exactly are these free-living amoebas, FLAs, you hear them called sometimes?
Right. Well, essentially, they're single-celled organisms, tiny life forms.
And they're just out there in the environment.
Pretty much, yeah. Found naturally in soil, in water, basically all over the globe. They're part of the natural world.
But not all of them are a problem, right?
No, exactly. The vast majority are completely harmless to us humans, but there are a few specific species that can cause severe, sometimes fatal infections.
And those are the ones we need to focus on.
Precisely. So for our deep dive today, we're really zeroing in on the three main culprits that pose a significant health risk.
Okay, who are they?
First, there's Naegleria fowleri. That's the most infamous one. Then Acanthamoeba castellani, often just called Acanthamoeba species. And third, Balamuthia mandrillaris.
Got it. Naegleria, Acanthamoeba, Balamuthia. But here's where it gets even more complex, right? Our sources suggest they aren't just direct threats.
That's a really profound point, actually. There are these emerging theories, two main ones that change how we think about, well, water quality.
Okay, what's the first one?
First, they might act as allergens. So think about inhaling amoebic antigens, maybe from humidifiers, potentially causing allergic pneumonia.
Wow, okay, allergens. And the second?
The second is maybe even more concerning. They can act like biological Trojan horses.
Trojan horses? How so?
They can actually harbor and protect pathogenic bacteria inside them, things like Legionella, Pseudomonas, even cholera vibrios.
The amoeba shields the bacteria.
Exactly. It allows these dangerous bacteria to resist things like chlorinated water, and that could potentially lead to hospital-acquired infections. It's like a hidden ecosystem in the water.
Making our usual defenses maybe less effective than we thought.
That's the worry, yeah.
Okay, let's zero in on the big one then. The one that grabs the headlines, Naegleria fowleri. The so-called brain-eating amoeba.
Right. And the key things here, thankfully, it's incredibly rare, but
Really.
it's almost always fatal, a truly terrifying reality.
And where does this thing live? Understanding its habitat seems key.
It is. That gives us clues for prevention. Naegleria fowleri thrives in warm freshwater.
Warm. Okay. How warm are we talking?
Typically between 25 to 35 degrees Celsius. So that's about 77 to 95 degrees Fahrenheit.
And where would you find water like that?
Think lakes, rivers, ponds, natural hot springs, even the warm water discharged from industrial plants.
Okay, natural sources mainly.
Mostly, but disturbingly, it can also show up in poorly maintained swimming pools, sometimes even tap water and water heaters if they're not hot enough.
Water heaters, really?
Yeah. What's notable is it's a facultative thermophile, fancy term, but it just means it loves heat. It can actually grow at temperatures up to 46 degrees Celsius, that's 115 Fahrenheit.
Wow. Okay, so how does this microscopic thing actually get inside you? Breach our defenses.
This is the absolutely critical piece. It has one specific, very dangerous pathway through the nose.
Only the nose.
Only the nose. Specifically, it targets the olfactory mucosa, the lining inside your nose, and the cribriform plate, which is a thin bone at the base of the skull.
And then?
From there, it begins this, well, horrifying journey. It literally climbs along the nerve fibers right through the base of the skull and directly into the brain.
Into the brain itself.
Yes. And once it's there, it starts consuming brain cells.
Yeah.
It does this piecemeal using a unique structure, like a little sucker on its surface. They're called amoebostomes.
It eats the brain. That's where the name comes from.
That's exactly where it comes from. It causes necrosis, hemorrhaging. It's devastating.
But let's be really clear here. How do you not get it?
Right. Crucial clarification. You absolutely cannot get PAMM, the disease it causes, from swallowing water containing Naegleria fowleri.
So drinking it is okay, or well, not okay, but it won't cause this infection.
Correct. The infection occurs only when contaminated water is forcefully pushed up into the nose.
Like diving or jumping into water feet first,
Mm-hmm.
or using a neti pot improperly.
Exactly, those kinds of activities. And also, really important, it does not spread from person to person.
Okay, good to know. Now, this amoeba has a pretty interesting life cycle, doesn't it? 3 forms.
It does, yeah. It's unique among these amoebas in that way. First, you've got the amoebic trophozoite. That's the infective stage.
The one that causes the damage.
That's the one. It's about 8 to 22 micrometers, moves kind of sluggishly. And in humans, it's the form that feeds on brain cells.
Okay, form 1. What's next?
Then you have the flagellated trophozoite. This is a temporary stage. It's pear-shaped, has 2 flagella, little whip-like tails for swimming.
When does it turn into that?
It develops when the amoeba finds itself in a hypotonic environment, like distilled water. Less salty, basically.
Does that happen in the body?
Well, this form can be present in cerebrospinal fluid, but it quickly transforms back to the amoeboid form within hours. Interestingly, this change is used diagnostically. It's called the flagellation test.
Huh. Okay, 2 forms. And the third?
The third is the cyst form. This is its survival stage, a resilient spherical capsule.
Like a little seed.
Kind of, yeah. It forms in the environment, in the lake or soil, to withstand harsh conditions, especially cold temperatures, below 10 Celsius. But notably, it does not form inside human tissue.
Only in the environment. Got it.
And just a quick point on identifying the dangerous one. There's a pathogenicity test. N. fowleri can grow at 42 degrees Celsius. The non-pathogenic Naegleria gruberi can't.
So that heat tolerance is a key marker.
It is. It tells you you're dealing with a dangerous species.
Okay, let's talk about the disease itself. PM, primary amoebic meningoencephalitis. What does it actually look and feel like?
Well, the onset is typically very rapid. Symptoms usually appear within, say, 1 to 12 days after that nasal exposure. The median is around 5 days.
And what are the first signs?
Early on, it can be subtle. Changes in taste and smell, maybe a headache, fever, nausea, vomiting, loss of appetite, things easily mistaken for something else.
Like the flu or meningitis.
Exactly. But as the infection progresses, the symptoms become much, much more severe. We're talking a stiff neck, confusion, a real lack of attention, loss of balance, seizures.
Hallucinations too.
Hallucinations, yes. And it progresses rapidly to coma and, tragically, almost always death.
Why? Why is it so deadly?
The fatality rate is just staggering. It's over 97%. Most patients die within 1 to 18 days, often just within a week.
It's incredibly fast.
It is. And a huge part of the problem is diagnosis. It's incredibly difficult because those early symptoms mimic more common things like bacterial or viral meningitis.
So you lose precious time.
Crucial time is lost. By the time PAMM is correctly identified, it's often simply too late for effective treatment.
Over 97% fatal.
That's just chilling.
Given how dire that is, what can medicine actually do? Is there any treatment?
There are treatments attempted, yes. The core drug is usually an antifungal called Amphotericin B.
Okay. Anything else?
Yeah, other drugs might be used in combination. Things like miltefosine, which is an antiparasitic, rifampin, azithromycin, fluconazole. Sometimes even therapeutic hypothermia cooling the body is tried to reduce brain swelling.
But does it work?
That's the challenge. There's no single guaranteed effective treatment. And as we just said, rapid diagnosis is absolutely critical, but it's so rare. Often the diagnosis is only confirmed after death, post-mortem.
Which just highlights how vital prevention is.
Absolutely vital. Awareness and swift action, if it's even suspected, are key.
Now, you mentioned it's making headlines. There seems to be a shift happening based on our sources. Tell us about these recent trends.
Yeah, this is concerning. Historically, in the U.S., most cases were in the southern states. Makes sense, warmer water.
Right.
But since about 2010, we've seen infections confirmed further north, places like Nebraska, Iowa, Minnesota, Indiana, Maryland, even Northern California.
So it seems to be moving, expanding its range.
It certainly appears that way. And then you look at Kerala in India, they've reported a really significant spike.
How significant?
Well, 36 cases in 2023 alone. Compare that to just 8 cases total in the 7 years before that, from 2016 to 2023.
Wow, that's a huge jump. And this year?
So far this year, as of September 2025, Kerala has confirmed 67 cases and unfortunately 18 deaths.
That's alarming. And there was that news about a survivor.
Yes, a recent, widely reported story, a 14-year-old boy in Kozhikode, India. He's reported as the first Indian to survive PAM, and only the 11th known survivor globally.
11th.
Yeah.
Out of how many cases historically? That puts the fatality rate in perspective.
It really does. It's a remarkable survival, but highlights the tragedy for almost everyone else.
So if we connect the dots here,
Yeah.
expanding range, spikes in cases, what's the bigger picture?
Well, climate change is a strongly suspected factor. It's hard to ignore.
How so?
As air and water temperatures continue to rise globally, these warmer conditions just create a more favorable environment for Naegleria fowleri to thrive, to multiply, and potentially expand its geographical reach.
Makes sense. And you mentioned young boys being affected more.
That's an observation, yes. Young boys seem to be disproportionately affected. The thinking is it might be due to recreational water activities, more diving, jumping, maybe stirring up sediment at the bottom of lakes where the amoeba might be concentrated.
Increases their chance of forceful nasal exposure?
Plausibly, yes. It makes you pause, though, doesn't it? Think about how resilient these ancient single-celled organisms are, adapting, surviving in environments we often just take for granted.
Definitely. Okay, so Naegleria gets the most attention, but you mentioned two others. Its cousins, you call them.
Right. Acanthamoeba and Balamuthia mandrillaris. They're also significant threats, maybe less known, but definitely deserve our attention.
Let's start with Acanthamoeba. Where do you find that one?
Acanthamoeba is very common in soil, actually, also water. But unlike Naegleria, its entry routes into the body are different.
Not just the nose, then.
No, it can get in through skin ulcers or through a traumatic eye injury. A big one is keratitis, a serious eye infection often linked to contaminated contact lens solutions.
Ah, the contact lens risk. I've heard of that.
Exactly. So Acanthamoeba can cause that chronic amoebic keratitis in the eye, but it can also cause granulomatous amoebic encephalitis, or GAE.
Another brain infection.
Yes, affecting the brain and spinal cord. And it can cause disseminated infections spreading through the body.
How is it different from Naegleria biologically?
Key difference. Acanthamoeba lacks that temporary flagellated stage, and its cysts, its survival forms, have a distinctive double wall which helps identify them.
And the GAE it causes. What are the symptoms?
For GAE from Acanthamoeba, you see things like altered mental status, headaches, fever, stiff neck, seizures, eventually coma. It usually leads to death within weeks to months.
And treatment.
Unfortunately, much like PAM, there are currently no really good diagnostic methods or reliable treatments available. It remains a major challenge.
Okay, so that's Acanthamoeba. What about the third one, Balamuthia?
Balamuthia mandrillaris. This one's a bit different. It's a leptomyxin amoeba. It's believed to be distributed globally, especially in temperate regions.
Found in soil and water, too.
Probably, but interestingly, it hasn't been definitively isolated from nature yet, though finding antibodies in healthy people suggests it is out there.
So we know people are exposed. How does it get in?
It's thought to enter typically via the lower respiratory tract, so breathing it in or through open wounds on the skin.
And what does it do?
Often, it might start as a skin lesion, one that's slow healing, doesn't respond to normal treatments. Then it can migrate to the brain.
To cause GAE again?
Yes, it also causes granulomatous amoebic encephalitis, GAE, which, like the others, is usually fatal.
Are its characteristics different?
It's quite large for an amoeba, 30 to 120 micrometers, and its cyst has a unique three-layered wall. Also, both its active form, the trophozoa, and its cyst form are infectious and can be found in brain tissue.
So the cyst can cause infection too?
With Balamuthia, yes. Symptoms of its GAE can include focal paralysis weakness in one area seizures and specific brainstem issues like facial paralysis or double vision.
Any survivors from Balamuthia GAE?
Very few. As of 2008, only 7 recoveries had ever been reported. And sadly, all of them had lasting neurological damage.
So across the board, with these 3, Naegleria, Acanthamoeba, Balamuthia, the outcomes are incredibly severe and treatments are limited.
Extremely severe, yes. Which brings us back to the most critical point.
Prevention. It really is paramount. It's your best, maybe your only, real defense.
You're absolutely right. Prevention is key. Though, it's often more complex in practice than just saying avoid it.
True. So let's outline some clear, actionable steps people can take.
Yeah.
What about recreational water, swimming in lakes, rivers?
Okay, for recreational water. First, try to avoid swimming or bathing in warm, stagnant, fresh water, especially things like shallow ponds or pools that look poorly chlorinated.
What if you were swimming in natural, warm, fresh water?
If you do, strongly consider wearing nose clips or at least consciously hold your nose shut when you're jumping or diving in.
Makes sense. Block that entry point.
Exactly. And in hot springs, try to keep your head above water altogether. Also, really important, try not to dig around or stir up the sediment at the bottom of lakes, ponds, or rivers.
Because that's where they live.
That's where the amoebas, especially the cysts, are likely to be most concentrated. Stirring them up increases the risk.
And pools, water parks.
For those, make sure they look well maintained. Proper chlorination is vital. The standard recommendation is generally above 0.5 grams per cubic meter of residual chlorine.
Okay. Now, you mentioned neti pots earlier. Nasal rinsing seems like a direct route.
It is a crucial area of risk, and one people might overlook. That tragic case we mentioned, the 71-year-old Texas woman.
Using tap water from her RV.
Yes, unboiled tap water for nasal rinsing. A fatal mistake. The rule here is absolute. For any nasal rinsing device, neti pots included, you must use water that is sterile, distilled, or tap water that has been previously boiled for at least 1 minute and then cooled down.
No shortcuts with tap water straight from the faucet.
Absolutely no shortcuts there. It's just not worth the risk, however small it might seem.
And just to reiterate, swallowing contaminated water is not the risk for these specific amoebas, right?
Correct. Swallowing is not the issue for PAM, GAE, or Acanthamoeba keratitis. And saltwater environments like the ocean.
Generally considered safe from these particular freshwater amoebas.
Good. Okay, that covers prevention pretty well.
But what's really striking here, I think, is the research looking at new ways to fight these things. Our sources mentioned a study on treating recreational waters.
Yes, that was fascinating. The challenge is significant, right? There's no universally agreed upon standardized way to completely eliminate N. fowleri in, say, large artificial surf lagoons or similar recreational water bodies.
So this research tried to find one.
Exactly. They tested different disinfection methods, and the findings were quite revealing.
What did they find about chlorine? Standard treatment?
Chlorination alone, even at a pretty standard level of 2 milligrams per liter, it did decrease the number of viable N. fowleri cells, but it did not eliminate them completely.
So it didn't kill them all off?
No. It seemed to have more of an amoebastatic effect, meaning it inhibited their growth, slowed them down, but didn't necessarily kill them all. They also pointed out that biofilms, that slimy layer inside pipes, can help the amoeba resist chlorine.
Okay, so chlorine alone isn't foolproof. What else did they test?
Ultraviolet light, UV treatment.
And how did that fare?
UV light alone, at a specific dose, they tested 60 milliwatts per square centimeter per second, was highly effective. It completely eliminated the viable trophozoites, the active form,
And the cysts, the tough ones.
and even the resilient cyst forms. So UV looked very promising on its own.
But the real breakthrough was combining them.
That's what was truly fascinating, the combined treatment. Using both UV light at that effective dose and chlorination together, specifically at 2 milligrams per liter with a sufficient contact time, they measured it as 52 milligrams per liter minute.
Okay, technical detail there, but the combo.
The combo achieved complete removal of N. fowleri trophozoites in their experimental setup. Total elimination.
Wow. So what does this mean practically for making water safer?
Well, it suggests this combined approach isn't just more effective at killing the amoeba.
It's better overall.
Potentially, yes. It could also be safer for swimmers because you might be able to achieve that kill with less reliance on very high chlorine levels, which reduces harmful chlorination byproducts.
That sounds like a genuine game changer for managing large recreational water facilities.
It really does. It offers a much more robust, potentially safer strategy for the future. A promising development.
Okay, so today we've really gone deep into this hidden world of free-living amoebas. From the notorious Naegleria fowleri, the brain eater,
To its equally concerning cousins, Acanthamoeba and Balamuthia mandrillaris.
yeah, we've looked at where they live, those sometimes horrifying pathways they take into the body.
The severe illnesses they cause, and underlined again and again the critical importance of, well, swift diagnosis if possible, but mainly robust prevention.
That fatality rate, especially for Pam, just keeps ringing in my ears.
It's terrifying, and it really underscores why vigilance is so essential.
And the rarity, while a small comfort, doesn't negate the danger, does it? Especially if changing climates are genuinely expanding their reach, pushing cases into new areas.
Absolutely. It impacts how we need to think about the safety of our recreational waters, our water sources generally.
But there is hope on the horizon, too.
Definitely. That research on combined water disinfection methods, using UV and chlorine together, it offers a really promising glimpse into how science is continually working to fight these kinds of unseen threats. aiming for a future where we can enjoy water with, perhaps, a bit more peace of mind.
So we'll leave you with this thought. We live in a world just teeming with microscopic life, most harmless, some incredibly dangerous, and often the most profound dangers can lurk in the most unexpected, seemingly innocuous places, a warm lake, a poorly maintained pool, even your own tap water if used incorrectly.
Mm-hmm. How might a deeper understanding of these hidden ecosystems, these tiny organisms, change the way you interact with your environment day to day?
And beyond these amoebas, what other invisible forces, what other microscopic dramas are playing out all around us, forces that we have yet to fully comprehend?